Here we are on the second and final video for section 5.4, and we're now ready to, well, we actually began or ended the last video with looking at rational expressions or rational functions and how can we tell inequalities there. But now we're going to look at it algebraically and how to determine that. Now, the big difference here is the fact that we actually need to get the zero to the one side. And so in this case, we need to get a zero here. So what we're going to do is we're going to subtract 1 from both sides. And realize that as soon as we do that, then we have to get this to become a we need to get our common denominator of x plus 8, because we do need to get this into a rational expression once again. So this will become x minus 9 over x plus 8 minus x plus 8 over x plus 8, all less than 0. And then this x minus x will cancel each other out. Negative 9 minus 8 is negative 17 over x plus 8 is less than 0. Now, how do we determine where the important points are? Well, the numerator we set equal to 0, the denominator we set equal to 0, and each of the points that we get from there are important points. So here, negative 17 equals 0 doesn't have any meaning. That's not going to give us any points. And x plus 8 equals 0 means x equals negative 8. So x equals negative 8 is where we will be testing. I'm going to try 0 because 0 is pretty easy and I know that it's up here. So I'm going to go back to the original and look true false and determine that. So if I plug in 0, negative 9 over 8. Negative 9 over 8 is negative 9/8. Is negative 9/8 less than 1? That is true. Now it's highly likely that this will be false, but let's pick a value, negative 10. Negative 10 minus 9 is negative 19. Negative 10 plus 8 is negative 2. Negative 19 over negative 2 is 19 halves. 19 halves is not less than 1, and so it is false. And so we need to go from negative 8 to infinity, and since there's no equal to, it's from negative 8 up to infinity. Number 8. X plus 7 times x minus 4 all over x minus 1 is greater than or equal to 0. So it's real nice. It's greater than or equal to 0 already, so we don't have anything special to do. We just have to set each one of those equal to 0 to find all of the important points. So x will equal 1, x will equal 4, or x might equal negative 7. So I'm going to choose negative 8. Negative 8, since it's 0, we can just worry about positives and negatives. So this will be negative times negative divided by negative. Negative, negative, negative makes negative. And so, is that greater than 0? No, that would be false. 0 is nice and easy for this number here. Positive, negative, negative. Positive, negative, negative is positive. Positive is greater than or equal to 0, so it's true. I'm going to choose 2. Positive, negative, positive. Positive, negative, positive is negative. Negative is not greater than or equal to 0, so that part of it is false. And finally 5, if I choose a value up here, positive, positive, positive. Positive, positive, positive is greater than or equal to 0, so that would be true. So that means from -7 to 1 and from 4 to infinity, it will be true. Since we've got equal to's, we can put these inside brackets, and we need to make sure that we combine those with the union. Example number 9. 9x minus 3 over x plus 8 is less than or equal to 8. Now this is what we're going to put back into check, but we first need to subtract 8 from both sides. And get a common denominator of x plus 8. I'm going to have to distribute that, so that will become 8x plus 64. And now I should be able to combine these into one fraction. 9x minus 8x is x. -3 minus 64 is -67. And that has to be less than or equal to 0. So setting each one of these equal to 0 so I can find the important point. 67 and -8 appear to be my important points. So I'm going to pick -10 and realize we could plug it in here also. -10 will be negative, negative. Negative over negative is positive, and that is not less than 0, so that's false. Plug in 0 here, negative and positive. Negative over positive is negative. That is less than 0. And then let's pick 100. That's pretty easy. Positive, positive, positive over positive obviously is positive, and so that would be false. So it's going to go between -8 and 67. We have the equal to, so the brackets will be included. So we're going to go from -8 to 67. Final example is number 10, and we have a word problem to finish this particular section. We're told the temperature is given with this equation: 4t over t squared plus 1 plus 98.6. T is the time in hours, and we need to determine the time interval for which the temperature is greater than 100. So we want to know when is this greater than 100. So first thing, subtract 100 from both sides, because we're going to get it to the 0. 4t, t squared plus 1. Subtracting 100 would be minus 1.4, greater than 0. Now we need a common denominator. That common denominator will be t squared plus 1. And then t squared plus 1. And let's see, it'll be negative 1.4 t squared plus 4t minus 1 when we distribute the negative 1.4, that is. So this is what we get, and it has to be greater than or equal to 0. So now we need to find the important points. Well, t squared plus 1 equals 0. Subtract 1, and we see nothing works here. But up here, what we need to do is we've got decimals, so we could try and factor, but the other way is let's try the quadratic formula. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is negative 4 plus or minus square root of 16 minus, let's see, don't know the exact value, but I do know that for this whole quantity here is equal to 8.16. So that's 8.16 all over negative 2.8. And then we do both the addition and the subtraction. So one of them will be negative 4 plus the square root of 8.16 over negative 2.8. And that equals 0.408. And the other one is negative 4 minus the square root of 8.16 over negative 2.8. And that is 2.449. And so that basically tells us where it's going to be greater than. It's going to be greater than from 0.408 up until 2.449.